So good news, this is the last chapter for the course. This is chapter 12, capital budgeting. So I'm going to break the chapter into two parts. The first part will be problems that are more personal in nature will help you understand the concepts. And then the second part will be business applications of the concepts. So, capital budgeting. What do we mean by a capital asset? We're talking about a long-term asset. And we know that assets are something that lasts for more than a year. So these are decisions that involve a short-term expenditure for a long-term asset and whether the future inflows will pay for the outflow. So we need to consider the time value of money when we do these calculations. And in your book, in your appendix, you will see 4 different charts. They look like this, okay? There are, as I said, 4. The first one is the present value of $1. What does that mean? So, if you're going to get $10,000 5 years from now, what is it worth today? Well, it's worth something less than $10,000, right? Okay. Second chart, present value of an annuity. So what is an annuity? Annuity is a stream of payments of the same amount. Again, it's important to remember it's got to be the same amount. So if you're going to get $2,000 a year for the next 5 years, what is that worth today? You would use the present value of an annuity table. Third table, future value of $1. If I put $10,000 in the bank today, what is it worth 5 years from now? So it's a one-time payment. Press future value of $1. Last chart, future value of an annuity. Again, what's an annuity? Those regular payments, equal payments. So if I put $1,000 in the bank every year for the next 5 years, what will it be worth 5 years from now? And all of this is hinging upon one concept inherent to all of it, which is that there is interest that is compounded and earned. So when we look at these tables, we are looking at 2 main pieces. The interest rates go across the top for all 4 charts, and the number of periods go down the side. So we have to find, obviously, looking for the factor, we need to apply the years and the interest rate. So I'm going to give you 2 examples, and depending upon how long this video goes, I may actually even put the second example in another video. So we'll see. We'll ask the videographer. First problem. So again, chapter 12. This is problem number 22. So I really like this problem because this is about retirement. And I know that you all are very young and retiring is the last thing on your minds. But the point of this whole problem is if you start putting money in earlier, it's worth more. So we are given this set of circumstances. We have a person who's going to either put in $2,700 a year for 25 years, or they're going to wait till they're older and put $4,500 a year in for 15 years. So the first question that we need to answer for problem number 22 is exactly how much cash is this person putting away? Well, $2,700 a year times 25 years, $67,500. And guess what? Same thing, $4,500 times 25 years, $67,500. $500. So we've established that they're putting the same amount of money in, but they're putting them in different time periods. This one they're going to do over 25 years. This one they're doing over 15 years. Now I'm highlighting these two things because we're going to need them for the second part. So the question is, if they leave them in for 25 years, what will this be? So the main question is, which chart should we use? So we're putting in an equal amount each year, and we want to know what it's going to be worth sometime in the future. Hint, hint, we're going to use future value of what? An annuity. Okay, so we'll go to our chart. Future value of an annuity. Now I highlighted, they give this in the problem. 10% is the interest. So if we look at 25 years down and 10% across, here's your factor, 98.347. So what is $2,700 times 98.347? It will be worth $265,537. Let's see, what about the later investment? 4,500 times, and now the factor off of the chart is 31.772. $142,974. So right away we can see a significant difference. Again, the person has put in the same amount of cash, $67,500, but by starting earlier and letting interest compound, the future value is $265,537 versus $143,000, round numbers. Last part of this problem. If this person lets this money sit, doesn't put in any more investments, but lets the money sit there for, let's see, how many more years? I think it's 10. If you let the savings continue to grow for 10 more years, what will it be worth? Now, here's the important detail, folks. Is this an annuity? No, because we're not putting any more money in. Is it a future value problem? Yes, but now it's future value of $1. So we're going to go to the future value of $1 table, 10 years, because it's sitting for 10 years, 10%. And here's our factor. So now we're going to multiply this pot of money here, $265,265 times 2.594. It'll help, me, 265,537 times 2.594. 688,803. Round numbers. Now, and notice, by the way, this is the same now because it's a future value of $1. So it's 10 years for both. So now I'll take the 142,974 times 2.594. 370,875, round numbers. So clearly, it pays for this person to start saving money earlier, even though it's a much lower amount, because they are still putting in the same. But look at the difference, folks. It's almost double. So this is an example of a future value problem, and we actually use two of the charts. We do future value of an annuity and future value of a dollar. And I think we will do the next problem in the next video. So I will see you all soon.